Hi all, this is Miss Englert, and these are your notes for Monday, April 12th, 2021, 8.5, what is humidity and how do we measure it? So for this first slide, what you're going to do is describe what you think the weather conditions are like in this picture using your five senses. You might have to use your imagination since you aren't there, but this was what the weather was actually like on Sunday, and you might be able to imagine that a little better. So you're going to say what you see. So what type of weather do you see? What do you smell in the air? What do you hear? What do you feel? And what do you taste? Because you can actually do all of those things. Remember that feel is not like emotions. That would be emotional feeling. This is like touch. So what can you feel on your hands? What can you feel on your face? Maybe if you walked in a puddle, what do you feel on your shoes? Anything like that. So this next slide, I accidentally messed up the Pear Deck on this, but you're going to answer anything that is underlined. So on this slide, you're going to write in, and you can just write the answer where it says answer here. You're going to write all the water vapor in the atmosphere is actually contained in the troposphere. So if you look on that diagram, there are water vapor concentrations, and after the troposphere, there is 0. So as you go to the right, we have higher concentrations of water vapor. As you go to the left, there is less. So as you move up the scale in altitude, after you leave the troposphere, there is actually no water vapor in the atmosphere beyond there. And then you should also know that temperature in the troposphere decreases with altitude. So if you look at our temperature gauge, as you go higher in altitude, your temperature decreases. So there are a couple words that we're going to learn today. The first one being humidity. So humidity is the amount of water vapor in the air. Where I grew up in Colorado, if it was higher than like 10% humidity, it was considered a humid day. Here in New York, I don't know what the average humidity is, but I think average humidity is like 50% humidity, like all the time. It's just very, very humid. So if you ever have like really bad hair days, it could be because of that humidity and your hair actually reacting to the water vapor that's in the air. It opens up the shafts of your hair, so you have like these scales on your hair. Each little hair has like these scales, these plates that line down, and the water vapor actually makes the scales kind of stick up, which makes them kind of turn and twist and pop all over the place. Sorry about that. My cat was dragging something on the ground. So on humid days, your hair might be a little bit all over the place, and that's because of the water vapor. Next slide. So slide number 4, this is a throwback for you all. Remember absolute age and relative age. So absolute age, we talked about this with rocks and fossils. Absolute age is an exact numerical age. So in this case, we know the ages of these people. So Jake is 2, Emma's 11, Pablo's 25. I can count. Relative age is when they compare the age to someone else. So Jake is the youngest. Emma is older than Jake and younger than Pablo. And Pablo is older than the rest of them. We're going to do this, not the same thing, but something similar for humidity. So we're going to talk about absolute humidity. Absolute humidity is the amount or mass. So this is actual, we measure this. So we measure the amount of or mass of water vapor in a given volume of air. So we tell that by saying how many grams of water vapor per cubic meter. So an air parcel is going to have a few different components. The 3 major components are going to be oxygen, nitrogen, and water vapor. So the more water vapor that's in the air, you can measure it, it will have a higher absolute humidity. The less or the fewer water molecules there are in that air parcel, the lower the absolute humidity will be. So relative humidity is going to be the amount of water vapor compared to the maximum amount that water can hold. And we're going to learn more about why different parcels of air can hold more water. But so if you look in this diagram, it's very cold in this first little parcel of air, and it kind of looks like a sponge. And if you notice that the water's actually overflowing from that parcel of air. And if you look, the temperature of that air is only 23 degrees Fahrenheit, which means it is actually below freezing, or it's negative 5 degrees Celsius. Compare that as you move up, as you move to the right, the temperature in this air parcel is 74 degrees Fahrenheit. So that's like a typical like late spring day, like perfect. You might want to bring a jacket later, whatever, or 23 degrees Celsius. So notice the warmer the air, so notice that the higher the temperature, these lines, if you draw a line, I actually do want you to draw a line on your notes. There's actually the same exact amount of water in each of those columns. These columns have the same, they have the same absolute humidity. So they actually have the same exact amount of water in each column, but they have less relative humidity as it gets warmer. So as you move up, so even though it has the same amount of water as this parcel, there's more dry air in this parcel. So that top is dry, and this is going to be wet air. So we have more dry air compared to wet air. So our amount of humidity is actually less than the absolute humidity all the way at the end, or so the relative humidity all the way at the end. So the reason why this is, I kind of skipped ahead, but that's okay. I like to talk about them together. So the amount of water vapor in the air, the amount of water vapor the air can hold depends on the temperature of the air. We did talk about that in the last slide. Let me explain why on the next slide. Oh, you can't write on this slide anyways. Oops. Oh well. Good thing I talked about it on the last slide. Okay. So our warm air, the reason why warm air can hold more water vapor, so this is a fact, warm air can hold more water vapor. This is because the water molecules are moving faster. So remember, when things are warmer, their molecules move around more, and heat is actually the measure of how much those molecules are moving. So those molecules are just moving too fast in warm air, and they can't actually condense. Whereas cold air does not hold water vapor well, so water molecules move slower, and they condense back to liquid more easily. So if you guys, well, I mean, you live in New York, so you're pretty well aware of the weather. During the summers here, it is gross. It is hot. It is hot, 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 and it is muggy. It is very, very humid. So anytime you walk outside in New York during the summer, you might start sweating like immediately. And the reason that is because it's so warm, and you might stay like sticky all day because the air is already full of water, and it doesn't actually evaporate the water off of your skin, so it just stays there, and then you just stay feeling kind of hot and gross. Then during the winters in New York, the air is colder, so it's drier. So the cold air does not hold moisture, which is why your skin might dry out during the winter, along with like the radiators and heating in the buildings, which does not do good things to your skin or your hair. All right, so one of our third to last slide is about saturation, and you'll write that word down. This is when a volume of air has all the water vapor it can hold. So whatever the air parcel is, if it is warm or cold, whatever it is, it can only hold a certain amount of air. And we'll look at some charts tomorrow that show you the relationships between how much water air can hold at different temperatures. So if we add any more water vapor into the air, or if the temperature cools below the dew point, and I'll explain what that is on the next slide, then if you add more water or it cools below the dew point, the water will actually condense back into a liquid. So different ways that this can happen are, I usually like to explain this in the classroom because during this time of the year especially, it's very humid and it's warm. So not only is it humid and warm in the rooms, but this is usually the time of year where there's a lot of sweaty teenagers in a classroom, so they turn on the air conditioner. And then when they turn on the air conditioner, the windows actually all fog up in the rooms. And that's because the air conditioner is cooling the air down below the dew point. So it means that the air has a lot of water in it, and the air conditioner actually cools down the air and it can't hold as much water, so that water is going to condense and precipitate out onto the windows, which is much more easily explained when you're actually looking at the windows and feeling how gross and muggy it is in Midwood. So relative humidity, we already did talk about this a bit. Relative humidity is the amount of water present in the air, and it's expressed as the amount needed to reach saturation. So if you look at those diagrams, these are the same diagrams as we saw on the other slides. However, if you look on the one on the left, it's at 100% relative humidity. That means that it cannot hold any more water, and all of the water will start condensing out at that point. The next one has 69% humidity, which means that 69% of this parcel is actually full of water. 26% is full of this water. So this is actually, once this air parcel reaches 26% humidity, it will start condensing out water, okay, as liquid water. And then the same things as we go. And notice that this guy is only at 15. So this air parcel can hold way, 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 way more water before it starts to condense out water in the form of dew or clouds. And it does that through the dew point. So the dew point is the temperature at which air becomes saturated. So this can happen in a couple of ways. If relative humidity reaches 100%, so either if you add more water or if you cool down the temperature, then water vapor begins to condense and clouds or fog will begin to form. So you guys might notice, as if you go out in the morning for like coffee, or, oh yeah, that's a good example. So if you go get some iced coffee, the iced coffee cup is cold because it's got ice in it, right? And as you're walking home, you might notice that there is water that starts to bead, like you see on this little ladybug here, or on this spider web. Water starts to bead on the cups, and that's water condensing. So the air is very, very saturated with water, and that coffee cup is nice and cold. So the coffee cup brings the air around it down to the dew point, and water gets to condense on the cup. And then your hand gets really cold and wet, and then you go home and drink your coffee. So whatever. All right, y'all, so those are your notes for today. Make sure you copy them all into your pear deck. I am grading one slide and one slide only. I will not tell you which one, so make sure that you complete all of them. And tomorrow we're going to learn more about relative humidity and absolute humidity. Alrighty, have a good day, y'all.